Happy snow day, FST students. Today we're just going to review some properties of exponents. We're going to apply it to some increase and decrease, exponential growth and decay. And then you have a little assignment to do. So just to review here, property of exponents. Remember these two properties right here when the bases are the same. So when the bases are the same and you are multiplying exponents, you're going to keep that base and add the exponents. When you are dividing two numbers with the same base, you're going to keep that base and you're going to subtract the exponents. These next two are when the exponents are the same. So on this side here, if you're multiplying and your exponents are the same, you can keep that exponent and multiply the two bases together. And the same as when we have the power of a quotient, you can see we can take the top to that power and the bottom to the power. Remember, power of a power, we're going to keep that base and we're going to multiply. Anything to the zero power, property of zero is always 1. Anything to the negative power, we're going to take the reciprocal of that base and take it to the positive power. All right, applying this, working through this a little bit, looking at this first one. In the parentheses, we are multiplying two numbers together. They do have the same exponent. So one way of doing this is I could write this as 8 to the negative 1, because I could multiply the bases together, keep the power. And then I have power of power, which would make it 8 to the first, which is 8. Another way, though, is I do have power of a product. So I could do power of power with each of these terms, which would give me 2 to the first times 4 to the first, which you can see is also 8. So a couple ways of doing that. This next example, this is one you got to be careful of because we have sum. We are adding in the inside. So remember, we don't have the power of a sum. So I got to work with this quantity on the inside. I do know 2 to the negative 1 is 1/2. 4 to the negative 1 is 1/4. So now I'm adding fractions. I could get a common denominator. 1/2 is 2/4. 2/4 and 1/4 is 3/4. And now, since I have just a single fraction, I could flip that because I'm taking it to the negative 1 power. This next example, you can see that we've got everything to the same power. Everything is to the n power. So I could combine those numbers. 8 times 3 is 24 divided by 4. I'm taking this all to the nth power. And 24 divided by 4 is 6. So I could simplify this to be 6 to the nth power. So that is an example, kind of a combined example of the power of a product and the power of a quotient. The next example, looking in the parentheses, we're adding here. Nothing I can do because they're not like terms. So I would distribute. So here I'm multiplying two numbers with the same base. I'm going to keep the base. I'm going to add those powers. Here I'm multiplying two numbers with the same base. I'm going to keep the base, add the powers, which is 0. Anything to the 0 power is 1. And so my final answer is x squared plus 1. These next two are, we haven't discussed something like this yet. So pay close attention here. If you look at this first one, we have a fraction. We are subtracting on the top. So again, they're not like terms, nothing we can do. But since we are subtracting on the top, I could look at this as a fraction. And I would have 3. I'm dividing two numbers with the same base. I could keep the base, subtract the powers, and 3 minus a minus 1 would give me 4. And then I'd have to look at this fraction. It would be negative. It would be 6. And then again, keeping the base and subtracting the powers would be a to the 7th. So that is when you're adding or subtracting on the top. This next example, you can see on the top here that I can multiply these. And I would get 50 a to the 3rd, b to the 6th. And then I'm dividing this by b to the negative 2. So I'd still have 50 a cubed, and then keep the base. 6 minus a minus 2 would be b to the 8th. So there's a couple more examples there. I'm going to give you a few on an assignment to do for today. The thing I want to talk about is exponential growth and decay. So when something is growing, so let's say something is increasing by 9%. We're going to talk about per year, but it could be per month, per game, per second, and so on. But if you're increasing by 9%, you're going to multiply by 1.09. Why is that? If you only multiply by 0.09, you would only get what it's increasing by. So we have to add 1 to that because we want to keep the original amount that we already had. So it's basically, if I have something worth $500, it'd be worth $500 plus 9% of $500. If I'm increasing by 2.5% per year, I'm going to multiply by 1.025, which is 1 plus 0.025. Changing that percent to decimal 2 places to the left. If you're decreasing, so if you decrease by 9%, now again, we want to know what we have left. So we're losing 9%, we would still have 91% of it. This 0.91 comes from 1 minus 0.09. So if I'm decreasing by 2.5% per year, 1 minus 0.025, I'd be multiplying by 0.975. So some examples here. Let's say I have a bike. Its rate of increase is 5%. Its cost right now is $200. So I would take 200 times 5%, 1.05 to the t power. If I have a pair of jeans that's worth 20, that's my initial amount. I would multiply by 1.08, 8% plus 1 to the t power. Then you can see the bread example. It's worth $1.25 now. If I multiply by 1.06, that means this must be increasing by 6%. Taking away the 1, changing it back to a percent. Doing the same type of thing on decrease. If you got a car, it's decreasing by 20%. If it's worth $9,800 now, my original amount, if it's decreasing by 20%, what I have left is 80%, which is the 1 minus 0.20. Got a boat worth $2,200. It's going to decrease or depreciate by 15%. So I'd multiply by 0.85 to the t, whatever the time would be. 1 minus 0.15. Skates, you can see you got $100. It's worth $100 now. I'm multiplying by 0.75, which is 25% less than 100. So this must be decreasing by 25%. So an example of this, if I got a Justin Jefferson rookie card who's on a tear, it's worth $85 right now. It's increasing by 3% each game. Find the value after 2 games. Well, original amount is 85. If it's increasing by 3%, it'd be 1.03 to the second power. So after 8 games, I would take 1.03 to the 8th power and multiply by the original amount, which is 85. And after 55 games, I would take 85 times 1.03 to the 50th power to find the value of that rookie card. Hope this helps. There's an assignment there in Google Classroom to complete. And then have a great snow day.